Hey everyone, Johnny here and welcome to another video. Today we're going to be looking at compound interest, what it is, where the formula comes from, and how to apply it. I'm going to explain the concept of compound interest using a basic example here that if we've saved $100 into a bank account that is paying us 12% interest per annum means per year, for 3 years, how much interest would we make? Now remember, the type of interest we're getting here in this example is compound interest, and the interest is going to compound annually in this example. Sometimes it compounds monthly, often it does do monthly. But in this case, as a basic example, we're going to say that the interest compounds annually, okay? It compounds annually. Now, what does that mean? It compounds annually. That means that the bank is going to reassess how much money I have in my bank account every year, and they are going to apply the interest rate here to that amount every year. So they are basically going to pay me interest every year. Because it compounds annually, they are paying me annually. The bank pays interest every year. If it was compounding monthly, the bank would be paying me interest every month. Okay, so that's what it means to have the interest compound annually. You'll understand the idea of compounding a little bit better once I go into this example. So, for 3 years, I go to the bank, I give them $100, but I don't go back to the bank for 3 years. I just make that one-off payment, that one-off deposit into my bank account, and they're telling me that every year I'm going to earn 12% interest on top of the $100. Obviously, when I go back to the bank in 3 years' time, they're going to have to pay me the $100 I loaned them, or that I saved, in other words. But they're also going to pay me more money on top of that $100 because it's interest. They are rewarding me for giving them money to hold for 3 years. Because they're actually going to then use my money to go and make themselves more money by lending that money to other people at a higher interest rate. But more on that in another video. So the point is, I'm going to make money just by leaving this $100 with the bank for 3 years. So what is my money going to be worth each year? Well, let's break it up year by year. Now, if you use the formula, which we'll come to after, you don't have to do this breakdown. I'm doing this so you can understand why the formula makes sense and what compound interest actually is. So, at the end of year one, what is the amount of my investment, we'll call it, the amount of my savings worth? I know that I saved $100, but I'm calling it an investment because I'm going to earn money in addition to that $100, okay? So I've invested it in a bank account. Now, after 1 year, of course the bank is going to owe me the $100 back still. Remember, they still owe me $100. So the amount of my investment after 1 year, I'm going to call that A1, the amount of my investment in total. It's the total amount, so it's including the interest and the original amount I saved, right, is going to be $100 plus they're also going to have to pay me interest because remember, it's compounded annually. So they are going to look at how much money I have in the account right now, $100, and because it's been in there for a year, they're now going to give me 12% interest. They're going to give me 12% interest on that $100. So you can see there are two parts to this. They not only owe me the amount that was already in there, but they now owe me 12% on top as interest. Okay, so 12% times $100 is $12. So I make an additional $12 on top of the $100 that they of course still owe me, which I gave them initially. So I end up with $112 as my total amount of my investment after 1 year. Now here's where it gets interesting. After the second year, what they owe me, and we'll do this same two-step formula here, what they owe me is still two parts, but it's no longer the $100 initially, because at the end of the first year, they owed me $112. So you need to understand that it's as if that I went to the bank after 1 year. Even though I didn't go to the bank after 1 year, it's as if I did, and I took out my $100, plus I received my $12 interest. So in total, I got $112 from the bank. And it's as if I then immediately put that money back in. So now the principal, which has been updated, right? They are going to update this principal to this amount. We go from $100 to $112. There is an update. So in such a way that $100 is no longer the principal. The principal, in fact, is $112. And when they give me interest, the interest they're going to give me is still going to be 12%. It's a 12% rate, but what is it? It's 12% of 112. It's not 12% of 100, because the amount technically that I have in that account now is 112 and no longer 100. So they've updated the number. So that's really good for me as a person who's saved the money. It's not good if you've borrowed, of course, because the interest you're making is going up each year or each month if it was compounding monthly. Okay, so it is compounding, it is increasing. Okay, it's not simply the same amount of interest each time. So actually, not only does the bank owe you 112 after the second year, based on the first year, but they owe you 12% of the 112 itself. And if you calculate that, that's going to come out as $13.44. Okay? So you can see that the interest in the first year was only $12. The interest in the second year is bigger. It's $13.44, because they've actually added that interest onto the $100 to make a new principal, to make a new initial investment, if you will. Even though it's not technically the initial investment, they treat it as if it is. Okay, so the total amount of your investment after 2 years, remember, you've never gone back to the bank, you just gave them $100 at the start of the 3-year period, is $125.44. Okay? What's going to happen in the third year, do you think? So if we go up to the amount owing after 3 years, well, remember how much we had by the second year. At the end of the second year, the bank technically owed us $125.44. Well, that's the amount that they are then going to treat as our new investment. It's as though we've taken that money out of the bank and put it straight back in. So the new principal is, again, not $100 and not $112. It's $125.44. And as before, you are then going to get 12% on that amount, not on the $100, not on the $112, but on that new updated amount. And once we add that on, we'll see that the amount after 3 years that the bank owes us is $140.49, and that's rounded to 2 decimal places. Okay, because the amount of interest here, and this is worth noting, the amount of interest here, which is given by 12% times 125.44, that amount is actually the highest amount of interest so far. Now we get $15.04 to 2 decimal places. So notice how the interest in the third year we got was $15.04. The interest in the second year was $13.44, and the interest after 1 year was only $12. So it is compounding. It is getting bigger. The interest each year is increasing. That's why we call it compound interest. The opposite of compound interest is simple interest. And simple interest would actually take that $100, multiply it by 12% to give you $12, and it would just keep giving you that $12 for as long as the investment went for. So you would get 12 plus 12 plus 12 under simple interest instead of 12 plus 13.44 plus 15.04. So you would only get $36 interest using simple interest, whereas with compound interest, you're actually going to, and you need to do this at the end, you need to minus the $100 to find the interest. Under compound interest, you actually make $40.49. Remember, under simple interest, you would have only made $36. You would have made $36 under simple interest at a 12% interest rate. So as someone who's saving money, you like the $40.49 interest more than $36. If you were borrowing money from the bank, you would prefer simple interest because you would owe them less. Okay, so the key thing to remember is that that amount of interest is getting bigger and bigger because the bank is recalculating the amount to which the interest is being applied. So even though it's 12% every year, it's 12% of a bigger and bigger amount each year because they're adding it on and treating it differently. And the formula here incorporates that. What I've just shown you is the behind the scenes footage, if you will, of the movie of compound interest. So basically we have this formula here, and when you use the formula, basically in one go, you're going to get the answer. You're going to get $140.49. You would get this if you entered in the information from that example. But you need to understand the behind the scenes happenings here to really understand how important compound interest is and how it actually works. Okay, so why does this formula operate as a shortcut? And just before I go into that, just note that when you do use this formula, you are finding the total amount, including the interest, the principal and the interest. So when you use this formula, it's not simply giving you the interest. The answer you get if you put in the principal and the interest rate and the number of years or months is actually going to include the original amount invested, such as the $100. So just like over here, if you use this formula and you want to find just the amount of interest, the amount on top, not the original $100 that you'll also get back, you'll actually have to minus the principal. See how I've minused $100 from this amount? You would have to do that if you use the compound interest formula to find just the amount of interest alone. Okay? The actual answer here includes the $100 initially, so we've deducted that off to get the interest. The formula won't do that for you. Okay, so keep that in mind, whereas with simple interest, the formula I equals PRN, you can see a separate video on that, will only give you the interest. So the two formulas are different in that way. Okay, so what we're going to do now is see where that formula actually comes from. Okay, so keep the other example in mind. Let's have a look here. So remember, the initial amount, right? The initial amount was $100 invested, and we call that the principal. So after 1 year, we have $100 that we are going to get back. If we were to go and pull our money out of the bank account after 1 year, even though we're doing it for 3 years, if we were to pull it out after 1 year, the bank would owe us the $100 based on the initial principal, right? Remember, that's the amount we actually put in. But they would also owe us, and this is important, they would owe us 12% of that $100, okay? Because they owe us 12% of whatever we actually gave them, because that's how interest works. So this bit here represents the interest. This is the interest, okay? And we know that's going to be $12 in this case. But what I want you to pay attention to here is how I can substitute the letters in for these numbers. So another way of writing this is after 1 year, the amount we're owed back is P. So notice this, it's P because the principal was $100. This means principal, okay? I'll write it down, I'll write it here. Principal is the initial amount. It's the initial amount you borrow or invest. Okay, so it's the principal, the $100, plus it's going to be 12%, which is the interest rate. And I'll do that in green. It's the interest rate, and we times the interest rate by the principal. Okay, so you're back to the P. See how it was 100 and 100? And remember that when you do this now, the times comes before the plus because you have to multiply before you add unless there are brackets. So that's the order of operations. So we can actually rewrite this as P plus RP. And then notice that we can actually factorize this because both of these two terms have P in them. So let's pull P out to the front. and factorize P out and put a bracket there, and we say P times what equals P, P times 1 gets us back to P, and then P times what equals RP, well, we would have to multiply it by R. So you can see here we actually get P bracket 1 plus R bracket. Okay, what I'm going to do as well, so it's super clear for you, is I'm going to rewrite this line in green. Okay, so 1 plus R. That is the amount that we are owed after 1 year. That's the interest plus the principal. It's the total amount. If I was to go pull out all of my money from the bank after 1 year, that is the amount they would owe. Hopefully you can see where that comes from based on that practical example I gave you. But I'm trying to use these letters now, these symbols, so that you can see where the general formula comes from. Okay, so A1 is the same as this. The amount they owe us at the end of the first year is the same as this. What about the amount they then owe us after 2 years? Well, remember, we no longer care about the $100 principal because the bank doesn't look at that anymore. All the bank looks at after the second year is how much they owed us after the first year. So obviously after the second year, they're going to owe us what they owed us after the first year, of course. But they're also then going to pay us interest on that amount. But they're not paying us 12% on the initial 100. They're paying us 12% on whatever they owed us in the previous period, which in this case was the amount after the first year. So you can see here that it's R times A1 plus A1. It looks exactly the same as P plus RP. You just have to remember that the only reason we're not using P is because this principal, this $100, has grown through compound interest to A1. So it's the same pattern emerging though. Hopefully you can see that. What I'm now going to do is what I did before. I'm going to factorize the A1 out. Okay, and then we're going to put brackets 1 plus R. And remember that A1 here is the same as P bracket 1 plus R. So I'm going to substitute that in because they're exactly the same value. Okay, so we're going to have P bracket 1 plus R times 1 plus R. So hopefully you can see that that part is given by that, and that A1 is that part. Okay, so it's the exact same thing. Hopefully you're following here. What we then can see is that these two brackets here are exactly the same. So in other words, A2, the amount owing after 2 years, is P bracket 1 plus R squared. So now you're seeing where this power comes from, because the bracket times itself, a bracket times a bracket that's exactly the same, is going to be that bracket squared, because there's two of them and they are multiplying each other. There's an invisible times between the brackets. And you can see importantly that the power here, the 2, corresponds exactly with the 2 down there. So if we were to keep this pattern going, you can imagine that A3 would simply be P bracket 1 plus R to the power of 3, because there, again, there's that correspondence between the month or year that you're looking at. In this case, year, the third year, will mean that we have 3 lots of compounds or 3 lots of interest applied, so the power becomes 3. Just like before where it became 2. That pattern would just keep continuing because you would keep multiplying the previous amount by that bracket 1 plus R. And because all of those brackets are exactly the same, they just keep adding to the power. So we can now get a general rule. We can say that the amount owing at the end of any particular year, represented by N, say I want the 5th year, it would be A5, equals P bracket 1 plus R to the power of that same number, N. So, for example, and that, by the way, that is the formula. We got there. That is the compound interest formula. That's how you derive it. And an example is if we wanted to find the amount owing of an investment after 5 years, all we would do is get the principal, put the interest rate in and the principal, and then put 5 up here. And you could just keep doing that. If you wanted to find the amount after 50 years, you would put 50 up there. So actually it's just the N that would change as you change the year, whereas the P and the interest rate stay the same. So that's how you use the formula. You can practice that with the example we used before, where you would find that A3 equals 100, which was our principal, bracket 1 plus 12% was our interest rate, and 3 years was the amount of years. if you put that into your calculator, you will find that that gives exactly what I found before when I did it without the formula, which is $140.49. Now remember, that doesn't represent the total amount of interest. You would then have to minus off the initial amount you did put in the bank on that very first day to work out the total amount of interest that you have made, which, as we said before, would be $40.49 of interest. Okay, so the formula includes interest and the original amount. Okay, hopefully that helps clarify where that formula comes from, and you can see that. One last thing worth noting for you is that sometimes, especially when it's not a annual compounding that's going on, so see back here where we said it was compounding annually, if for any reason it says compounding monthly, which is actually more common in the real world, when you get your interest from the bank, it is usually compounded monthly, so they are recalculating your interest every month and adjusting that initial amount that they're putting into the formula, right? Not this P rather, but the A1, as you saw, the A1 changes to A2, changes to A3. That amount may change every month. And if you do get a question where it is compounding monthly, sometimes it will say compounding biannually, which means twice a year, right? Whatever it says, you want to pay close attention to that word there next to compounding. Because if it was compounding monthly, and remember in our example we said that the interest rate was 12% per annum, you can see that there's a disconnect here. It's compounding monthly, and yet they've given us an annual interest rate, which means every year. So what you then have to do when you use the formula is you have to first divide this rate by 12 to then give you the monthly interest rate. Because there are 12 months in a year, you want to chop up that annual interest rate into a monthly by dividing by the number of months there are in a year. So you end up with 1% per month. So that's the number you use in the formula. And you can also use that as 0.01. That is the decimal equivalent to 1%. So we could have used 1 plus 0.01 if we had monthly compounding. Okay? That's the first thing you have to change. There's two things you have to change. The second thing you have to change then is the N. Remember this number up here where we were putting 3? Well, if we had an investment for 3 years, but the interest was compounding monthly, then even though it looks like N equals 3 years, remember there's a disconnect because it's compounding monthly, not yearly. I don't care about years. I care about months. So what you then do in this case is the opposite to what we did to the interest rate. See how you multiply 12% by 12 because there are 12 months? Here, we would multiply 3 by 12 because there are 12 months in a year. And that means the total amount of months is 36 months. And that's the number you would want to put into N. So instead of putting 3, you would put 36 if it compounded monthly. And instead of putting 12% there or 0.12, you would put 1% or 0.01. Okay, you have to make sure everything is in the same terms as the compounding period here. So if it was month, you do it as I just said. Otherwise, if it was year, you go back to how we initially did it. All right, I hope that helps clarify a few things around compound interest. You can see where the formula comes from. You can see how easy it is to use. Hopefully you understand the adjustments that may need to be made. If you enjoyed the video, please like and subscribe. Comment below if you have any questions or particular examples you want me to work through, and I will see you in the next video.